Maintenance Supervisor, Chief Mechanic, MS, course. This training course aims to provide offshore maintenance supervisors and chief mechanics with the necessary skills and knowledge for effectively managing and maintaining critical equipment in remote offshore environments. Course Overview 1. Comprehensive Program. This course provides a comprehensive understanding of maintenance management, leadership, and technical skills necessary to effectively oversee maintenance operations. 2. Target Audience. The Maintenance Supervisor, Chief Mechanic MS course is designed for experienced maintenance technicians, mechanics, or engineers who are looking to advance their careers into leadership roles. 3. Accreditations. Maintenance Supervisor or Chief Mechanic MS course is approved by LISCR. Roles and Responsibilities of Maintenance Supervisor and Chief Mechanic. Maintenance Planning. Develop and oversee the implementation of comprehensive maintenance schedules and procedures to ensure optimal equipment performance and reliability. Troubleshooting. Diagnose and resolve complex mechanical, electrical, and instrumentation issues through expert analysis and hands-on repairs. Team Leadership. Provide technical guidance and mentorship to the maintenance crew, fostering a culture of continuous improvement and safety. Operation and Maintenance of Engines. 1. Engine Maintenance. Proper maintenance of marine diesel engines is crucial for ensuring reliable performance and extended lifespan. This includes regular oil changes, filter replacements, and monitoring of engine parameters. 2. Engine Room Operations. The engine room is the heart of an offshore vessel, housing the main propulsion engines as well as auxiliary systems. Careful monitoring and troubleshooting of engine room equipment is a core responsibility of the maintenance team. 3. Overhaul and Repair. When major engine issues arise, the maintenance team must be prepared to oversee complex overhaul and repair procedures. This requires strong technical expertise and coordination with OEMs to return the engine to optimal condition. Detection of machinery malfunction and faults. Vibration analysis. Utilize vibration sensors to detect abnormal vibration patterns that may indicate bearing, gear, or shaft issues in rotating machinery. Analyze the frequency and amplitude of vibrations to pinpoint the source of the problem. Thermography. Employ infrared thermal imaging cameras to identify hot spots, which can reveal overheating components, inadequate lubrication, or other malfunctions. This non-invasive technique allows for early detection of issues. Oil analysis. Monitor the condition of lubricating oil through regular sampling and testing. Changes in oil viscosity, contamination levels, and where particle analysis can indicate impending component failure. Acoustic monitoring. Use ultrasonic sensors to detect high-frequency sounds that can signify developing problems such as bearing wear, gearbox issues, or valve leaks. This method is effective for identifying incipient faults. Operation and Maintenance of Fire Detection and Control System. Fire Detection. Proper placement and maintenance of smoke detectors, heat sensors, and other fire alarm components are crucial for early warning of fires offshore. Firefighting equipment. Ensuring fire extinguishers, hoses, and other firefighting equipment are well maintained and readily accessible is essential for containing and extinguishing fires. Emergency Response Plan. Regular drills and reviews of the emergency response plan help the crew respond quickly and effectively to fire incidents offshore. Cranes and mooring systems. Offshore cranes are crucial for heavy lift operations, cargo handling, and equipment maintenance. Proper operation and maintenance is essential for safe and efficient offshore operations. Mooring systems securely anchor offshore rigs and platforms to the seafloor, ensuring stability in rough seas. Effective management requires specialized knowledge of load capacity, weather conditions, operational procedures, and maintenance protocols. Comprehensive training for maintenance supervisors and chief mechanics is crucial for safe and reliable performance. Iron roughneck and HTV pipe handler, tongs, mud basket and slip automation. Offshore drilling operations rely on specialized equipment to handle pipes, tongs, and other critical components. The iron roughneck is an automated pipe handling machine that grips and turns the drill pipe, while the HTV pipe handler efficiently moves and positions the pipes. Tongs, mud baskets, and slip automation systems work in tandem to secure and control the drill pipe, ensuring safe and efficient operations on the rig floor. Marine riser telescopic joint and rotating joint for DP ships. Offshore rigs and platforms use specialized marine riser systems to transport oil, gas, and drilling fluids between the seafloor and the surface. The telescopic joint allows the riser to extend and retract, accommodating the vessel's vertical motion during dynamic positioning DP operations. The rotating joint enables the riser to rotate with the vessel, preventing damage and ensuring a stable connection. These components work together to maintain a secure, flexible riser system that can adapt to changing offshore conditions. Subsea BOP control system and hydraulic, electric and acoustic arrangements. Hydraulic control system. The subsea BOP utilizes a robust hydraulic control system that powers the various functions of the blowout preventer. This system ensures reliable and precise operation of the BOP components even in deep water environments. Electric control system. In addition to the hydraulic system, an electric control system provides a redundant means of operating the BOP. This backup capability enhances the overall reliability and safety of the well control equipment. Acoustic backup system. An acoustic communication system serves as a last resort for BOP control in the event of a hydraulic or electrical failure. Acoustic signals can be used to trigger critical BOP functions from a remote location. Course curriculum, operation and maintenance of engines. Operation and maintenance of auxiliary machinery. Detection of machinery malfunction and faults. Maintenance and repair problems. Operation and maintenance of fire detection and control system. Safe working practices. Maintenance of survival craft and launching appliances. Pollution prevention procedures, cranes and mooring systems. Top drive configuration, traveling and crown block arrangements, Kelly and rotary table arrangements, draw work and braking system, mechanical brake, O-brake and disc brake, iron roughneck and HTV pipe handler, tongs, mud basket and slip automation. Shale shaker, design and maintenance, desander, desilter and mud centrifuge, mud gas separator, and vacuum degasser. Cementing unit, batch mixers, silos for cement and barite and transfer system to hopper. Triplex mud pump, pulsation dampener, suction dampener and mud agitator. Marine riser tensioner and traveling block heave compensator. Marine riser telescopic joint and rotating joint for DP ships. Surface BOP control system and hydraulic arrangements. Subsea BOP control system and hydraulic, electric and acoustic arrangements. About us. Elite Offshore Private Limited, established in 2015, is a leading provider of offshore, marine and industrial safety and skill training and certification programs. With a commitment to safety, compliance, and excellence, we empower professionals worldwide with the knowledge and skills they need for success in their careers. Academy was established in 2021, serves as our specialized division, providing customized e-learning solutions designed to meet the specific needs of the industry. Through Academy, we offer the IADC-accredited RigPass online course alongside other valuable e-learning programs like IMDG code courses, basic first aid, and more. Contact us for more information. You can call us, email us, or go through our website and visit us at this address.